Welcome to our channel. When you look down at the ground, what do you really see? For most of us, it's just dirt, right? It's the stuff that holds up trees and, gets on our shoes. But what if I told you that in a single handful of healthy soil, there are more living things than there are people on this entire planet? Seriously, today we're going to dig deep and uncover this bustling universe that's happening right under our feet. Okay, so let's just jump right in. For the longest time, we've had these two totally different ways of looking at soil. On one side, you've got the whole inert dirt idea. It's basically just a physical anchor for roots, a pot that you pour chemical nutrients into. But the other view, the one we're really exploring today, sees it as a living ecosystem, a complex underground city with billions of microscopic citizens all working together. And let me tell you, the difference between these two views changes everything. So this brings us to a whole new way of looking at soil. We are talking about a major shift in thinking here. It's moving away from that old idea of just, force-feeding plants with liquid chemicals and moving towards a much more elegant understanding of soil as this living, breathing, self-regulating superorganism. And what's really interesting here is that this isn't some new debate. As this quote points out, there have always kind of been these two schools of thought. But what is new is this science that's now proving just how powerful and sophisticated the biological approach really is. This isn't just about being organic, it's about engineering an entire ecosystem. So to really get this living ecosystem, we first have to understand the house it's built on, the actual physical and chemical properties of the soil. And this is where we find one of the most crucial concepts for soil health, its ability to store and exchange food. Think of it like a battery. That brings us to this slightly sciencey term called Cation Exchange Capacity, or just CEC. Now, I know it sounds complicated, but the idea is actually super simple. It's just a measurement of the soil's potential fertility, basically how much plant food it can hang on to at any one time. It's like the size of the pantry in your kitchen. And this, right here, is the perfect analogy. A soil with a high CEC is like a high-capacity, rechargeable battery. It can store a huge charge of nutrients and then release them whenever the plant needs them. On the flip side, a sandy, lifeless soil, that's like a cheap battery that dies in 5 minutes. So how does this battery actually work? Well, it's basically just magnetism. Tiny little particles of soil, especially bits of clay and that dark, rich stuff called humus, are all negatively charged. So nutrients like calcium and magnesium, which are positively charged, are attracted to them and they just stick right to the surface. It's like tiny little magnets holding onto the food, preventing it from just washing away in the next rainstorm. Okay, so if you have a rechargeable battery, you have to charge it correctly, right? Well, according to the work of a soil scientist named Dr. William Albrecht, there's an ideal balance for these nutrients. You want that battery mostly charged up with calcium, somewhere around 60 to 70%, and then smaller amounts of magnesium and potassium. This specific ratio doesn't just feed the plant, it literally builds a better house for the roots to live in. And this is exactly why that ratio is so important. Calcium has 2 positive charges, and it's a big ion, so it kind of acts like a bridge, pulling tiny soil particles together into nice little clumps. This creates a loose, airy structure with plenty of room for air and water. Magnesium, on the other hand, is a smaller ion, and it pulls the particles way too close together, creating a tight, compacted soil that plant roots can barely breathe in. Getting this balance right is literally the difference between a fluffy cake and a dense brick. Okay, so we've got our soil battery, and we've charged it up with the right balance of minerals. Awesome. But how does the plant actually get the power out of that battery? Well, that's where the living part of living soil comes in. This is the great microbial exchange. This quote right here, this is the central mantra of this entire philosophy. Instead of trying to spoon-feed the plant exactly what you think it needs, you focus on creating a thriving city of microorganisms. You feed that tiny city, and in turn, it takes care of feeding your plant perfectly. So how does this whole biological feeding thing actually work? Well, it's a process some folks lovingly call the poop loop. It all starts when bacteria and fungi break down organic matter, and they suck those nutrients right into their own tiny bodies. But if it stopped there, the plant would starve. The magic happens next with predation. Tiny predators like protozoa and microscopic worms called nematodes come along and gobble up those nutrient-packed bacteria. And that brings us to the final, absolutely crucial step. See, the bacteria are super rich in nitrogen, but the predators that eat them don't need all of it. So what do? They excrete the extra nitrogen as waste. And guess what that waste product is? It's ammonium, A perfect ready-to-eat meal for the plant, delivered right to its doorstep, exactly when it needs it. Without the predators, the entire nutrient cycle just grinds to a halt. This whole system is it's incredible, isn't it? If you're finding this as fascinating as I do, please like and subscribe. It really helps our channel a lot. Your support is what lets us keep making more content like this. So, now that we've got the theory down, we've got our charged battery and our living workforce, let's get practical. How do people actually build this stuff in the real world? Let's look at a couple of popular blueprints. In the world of high-value growing, two really famous recipes stand out. They're Subcool's super soil and the Clackamas Coot method, and they have very different philosophies. The Subcool method is all about being front-loaded. You pack in everything a plant needs for one entire life cycle. The Coot method, though, is about creating a permanent, sustainable soil that you can use over and over for years, and it just gets better with time. The Subcool method is famous for this cook and layer technique. You mix up this really rich blend of nutrients, and you let it compost or cook for a month or two. Now, this hot soil is way too strong for a baby plant, so you layer it at the bottom of the pot with just plain soil on top. As the plant gets bigger, its roots grow down into that super rich layer, finding all that food right when it needs it most. It's pretty much a just add water approach for a whole season. Now, the Coot method is all about balance and reuse, following what's called no-till gardening. It starts with a simple, perfectly structured base. 1/3 peat moss for holding water, 1/3 something for aeration like pumice, and 1/3 really high-quality compost for all the microbial life. Instead of hot preloaded meals, it uses slow-release rock dusts and minerals to create a super stable, long-lasting soil that you never, ever have to throw away. So, you see, whether you're building a soil to last for just one season or for a lifetime, both methods are really based on the same fundamental shift in how we see things. It's a philosophy that sees the plant not as some passive thing waiting for food, but as the conductor of the entire orchestra. And this right here is probably the most amazing takeaway of all. Plants aren't just sitting there waiting for a handout. They are actively farming the soil. They take up to 40% of the energy they make from sunlight and pump it back down through their roots into the ground. This energy, which comes out as these sugary exudates, is like a custom-made meal designed to attract and feed the exact microbes they need to unlock a specific nutrient. The plant is totally in control, intelligently managing its own microscopic workforce. So, the point is, soil isn't just some static thing. It's a dynamic, intelligent system, a partnership between plants and microbes that's been perfected over millions of years. Which really just leaves us with one final question. The next time you walk outside, what are you standing on? Is it just dirt, or is it a universe? Hit that like and subscribe. Thanks for watching. This content does not constitute medical advice, legal advice, or recommendations for the use, self-treatment, or consumption of any substance.